let's talk about Python numbers. Hi everyone, Chandan this side, and as I said, today we will be starting off with Python numbers. So let's get started. As you know, we are using Google Colab. So what we will do, we will get into Chrome first. In Chrome, we'll simply type Google Colab. You'll get this screen open up, and I will open up a new notebook. We'll simply have to type Google Colab and it will come up. Let me zoom it in for you. I think, yeah, I think they should do right. Okay, so Python lesson numbers. Okay, so that's what we are going to be talking about. Okay, so we'll be covering a number of things today. Let's explore. Obviously, we'll be talking about numeric types. We'll be talking about numeric literals. We'll be talking about conversions. We'll be talking about int, float, and complex type of numbers. Okay, so the very first one that is our primary direction where we will go is integer type numbers. Okay, what are these basically? These are basically values like this where you don't have a decimal point or anything of that sort, right? 10, B, 20, whatever is there. So if you go ahead and if you print them, okay, it takes some time to get connected on the runtime. So yeah, you can see. Same way if you do print type A, yeah, class integer. Remember the way we talked about class str or string? Same way it's a class integer, okay? Now if I talk about floating point number, so that's basically where you have a certain decimal point. Let's say 10.56. So if I do print B, if I do print type B, you'll get class as float. Okay, integer and float. Now, these two are relatively simple. Okay, where a little bit confusion comes along is complex type of numbers. Why? Because these numbers have two parts. One we call it as a real part of the number, and there is an imaginary part of the number. Okay, to understand the real part and the imaginary part, first let's go ahead and look into a complex number and how does that exactly look. So let's say I'm writing something like this. Okay, 4j, and if I print C and then if I print type of C, you can see the class is written as complex. Okay, now what it is, why have I written 4j? So let's say if I do this, print, sorry, print C is my number, c dot real, and if I do this c dot image stands for imaginary, okay. You can see 3.0, 4.0. 4 is basically my imaginary number that comes up here. But why exactly the requirement of this imaginary number came up? So here is the thing. Most of the videos in the internet might not be telling you this, and there might be some who would be telling you this. Imaginary number, part of the number, I would say, of the number provides you a squared value in negative 1. What do I mean by this? Let's say you are squaring any random number, okay? Let's say you are squaring 2, okay? So let's say d, I'm squaring it, 2 multiplied by 2, print d, it will come up 4, right? If I, let's say, if I, let's say, do this, sorry, g, let's take g equals to e dot f, sorry, e multiplied with f. Even if I print this, you'd see that I'm getting 9, which is basically a positive number, right? So any squared value always comes up into a positive. But in real world scenario, we come across needs where squared values are needed in negative. Few of the use cases are, I would say, wave motions, right? The electricity wave motions, then game, like online game figure rotation, etc. Okay. So for these scenarios, it provides you a particular value. I have written this j, na, like where it is, yeah, this j. This j is the part. If you square this, j square will always return you a -1. Okay. Now, I understand this is a little bit complex. The name is complex only, but in our working scenario, you would not be encountering a complex number too much of a time, right? So that is something I can tell from my experience. It's not like to be likely to be there. Most of all, it's integer and floats only. Okay. Now, integer have a variation. It's called long integer. Why it is required long integers? So let's say a value is something like this, right? Let's say it's 100,000, okay? So for our understanding, if I talk about regularly when we write numbers like this, what do? We generally put up a comma, right? Let's say the number is too big. So just that we understand that what the number exactly means, what do? We put up comma to separate the number. But if I go ahead and try to print this, see what happens. It is treating all of these numbers separately. So 100 is being counted as a number, and then the rest it is saying all three zeros. So it is considering that these are different numbers. So I'm not getting the exact number, right? So to avoid such scenario and also to make sure that we understand what the different numbers are denoting us, what we handle it like this. We provide underscore. So 100 underscore triple zero, then again triple zero, and then if we print y, it is going to give us the complete number. Clear? Now when we talk about numbers, by default arithmetic operation comes into the discussion, right? That how we can perform different arithmetic operation in Python. So that can be done. So let's say I'm taking two variable a and b and I am assigning two different values, let's say 10 and 5. Okay. Then I am trying to perform different functions. Let's say print a plus b. Okay. I'm getting 15. Okay. Now plus if you do negative, if you do multiplication, you get all of these things, right? These are very common. If you do division, you'll get 2.0, right? Now there are like subtraction, addition, division are something pretty common, so I'm not making different sections on that over here. I mean, I can simply write uh, plus, minus, multiplication, division, etc. there. Okay, these arithmetic operations can be executed with numbers. Okay, where I would like to draw your attention is few other kind of operators. Let's say floor division. Now what exactly is floor division? Let's say I'm trying to do this. I'm getting 2 because right now it is divisible, right? 10 is divisible by 5. But let's say I'm doing this. C and D, I'm assigning, let's say 10 and 3. Okay, two different values. And then I'm trying to do this. What am I getting? 3 into 3, 9. 1 is still left, right? So what float division does, gives you the float number without the remainder. Okay, clear? Now, you might ask, in that case, do we have something with the help of which we can get the remainder? Of course we do. There is an option. Sorry, remainder. Okay. So if you want to find out the remainder, C and D are our variables, right? So what you can do, you can simply do C. What is the symbol? Yeah. Okay. You get 1. This is your remainder. Okay. And then if you want to find out number to the power, okay, so you can also put that up. So if I simply do print C D, it will give you what? It will give you 10 to the power 3, which is coming up to 1000. Okay, clear everyone? Now let's talk about something called augmented assignment. What exactly is augmented assignment? Let's say there is a value, okay? And if you want to add something to this, what we generally do, let's say I want to add 5 to it, right? So maybe we take a separate variable, we assign it a value, and then we take up the value, right? So let's say no equals to 5, then print n plus o, something like that, right? It gives you 15, okay? But with augmented assignment, what happens? You already have the value of 10, right? So what you can do, you can simply go ahead and print n plus equals to 5. What does this mean? This simply means that you have a end value that you want where the total value should be added with n, and n's value we already have as 10. Even if I remove this, invalid syntax, why? Okay, let me check once. Oh, my bad. The issue over here is it directly does not take into the print statement. What you need to do, if I simply run this, okay? If I simply run this, what it will do? It will add the value to n, okay? So let's say I'm doing this. See, it got perfectly executed. Now after this, if I go ahead and if I print the value of n, it is going to give me 15. Okay, so this is called augmented assignment. Now after this, you can also do this. Let's say n negative equals to 2. Okay, done. It worked fine. If you print n, it is going to give me what? It is going to give you 13. Okay, because 15 minus 2, 13 comes up. Clear, everyone? Now, something to remember is called type conversion. Very important. Why? Because a particular variable should be of a should be of a type to perform some kind of operations with it, right? Let me explain. So let's say if you have a equals to 10, b equals to 20, you can simply do print a plus b. Okay, it will give you 30. But somehow, if your a is remaining within quotes, then what? A is actually a string, right? Then if you try to execute this, it is going to throw you an error. It will say can only concatenate str, not int to str. That simply means both are not integer type of data. Hence, they are unable to perform a addition operation in between them, in between the same, right? That's why type conversion is very important. What is type conversion? Type conversion is nothing but you are declaring that whatever was there in the a value, you are converting that into an integer. Okay, done. See, now it is converted into a 10 numeric and I'm getting print a plus b at 30. Okay, very important type conversion. Now obviously this is only possible where the string value is actually a number but somehow given as a string. If without that, if you have given a string value, right, Harry or something like that, right, and if you try to execute, it will throw you an error because although you tried to convert this Harry cannot be converted into a numerical factor, right? Only a number can. Clear, everyone? Now, just like the keyword library that you talked about earlier in the variable lesson, there is a library called math, okay? A very basic mathematical function library which has some mathematical function, right? Square root, power, cos, sin, and all of that, right? So let me just give you an example. Let's say if you want to perform square root of a number, you can simply pass on the number, it will give you the result. Okay, but we are not going to focus much on the math library because down the line we will be covering the greatest library that is there in Python for mathematical operation, which is called the NumPy. Okay, so it's way down the road, not right now, but yes, we'll be covering that in detail. Okay, clear, everyone? Okay, let me make this a comment so that this does not become a problem. Okay, all right. So let's keep it till here. I'll see you in the next video. Please subscribe. I mean, as I said that I am not really used to saying these things, but yeah, do subscribe and I'll keep making contents for all of you. Thank you.